Welcome. So, last module or series, a short lecture, we have seen about the discrete components and we have seen about the breadboard, right. This particular module we are focusing on measuring the values of different components, right. So, let me introduce the teaching assistant Sitaram Gupta. He will be showing you how to use the components, and as and when he is using the devices or using the equipment, I will tell you how the equipment works, how you can use the devices, alright. So, we will start with measuring the resistor. So, resistor we have seen in the last class resistor, right. Now, what is the value of the resistor that I am holding in my hand? If I can see, this is a resistor in my hand, right. Now, what is the value of this resistor? Alright. So, for that I will give it to Sitaram and let him measure the resistance, and you can you focus on this particular multimeter, how he is measuring the resistance. Alright. So, you can see the first thing that he is doing is he is using the resistance, right. You see resistance he has kept around 20 kilo ohm. So, you can start at any value if you do not know the value, and you can keep on increasing the this probe to higher values. So, the first thing he has tried 20 kilo ohm. Okay, let us see now. So, when we see the resistor, the probes are connected, you can see here, right, the probes are connected, and when you connect the probe, you can take it in hand and you can connect it like this, yes, and when you connect it like this, right, you can see the value. Can you see the value here? Can you please focus here? Yes. So, what is the value you are looking at? You are not looking at any value, right, is it? You cannot measure any value. So, now we are increasing the value, right. Initially it was 20 kilo ohm, here you cannot see anything. So, now we are increasing it, right, and then we start looking at 40. So, what is 40? 40 is in 2000. So, what is the value of this one? Around 320 kilo ohms, around 310 kilo ohms, right. So, this is fluctuating because he is holding with hand. In reality you do not have to hold with hand, you can always use the breadboard and you can insert the resistor, and then you can again measure the resistance. So, when you insert the resistor like this and then you measure it, right, you will be able to see the value which is more appropriate here. If you see now is almost constant, right, it is almost constant. Earlier it was like 31, 32, because he was holding with hand, the connection were not proper. Now, in this case when you see it is almost constant. Whatever are we using? We are using breadboard, alright. So, now let us go to another resistance, right, another resistor. So, this is another resistor that I am giving it to him, he is inserting it into the breadboard. Now, you again let me reiterate that you may think that this is so easy, we know, but even it is important to understand, alright. So, always understand even you know something. What is the value? Now, you see value is extremely low. So, if we go down, can we go down and can we see still? Yes. So, this is around 20 kilo ohms. So, you can see 2.14 kilo ohms, around 2.14 kilo ohm is the value of this resistor, right. Now, if you want to measure, so this is about the resistance, so easy to measure. Similarly, if we have multimeter which is not the yellowish one, right, which has different kind of settings. So, here if you want to use this multimeter, like I have shown you in the last module, we can keep it in the resistance mode. So, this is the resistance, frequency, capacitance, everything can be measured in the same place. So, now if for this, these are the probes, he is again connecting this probe to a resistor, you see resistor, right, again it is showing some value, alright. So, this is in auto mode. So, it will automatically measure the resistance of the resistor, alright. If you connect to another resistor, you will see another resistor he is connecting and we are getting the value around 2.161 is even more accurate compared to the another one. But again let me tell you this thing, that we are not interested in understanding the accuracy right now, not resolution right now. We are understanding that how we can use the multimeter for measuring different components. All right. So, this is the how the resistors can be measured. All right, excellent. Now, let us move to the another part, which is the capacitor. Now, can you measure the capacitor using this multimeter? Can you measure capacitor? Can you see there is a capacitance value? No, is it? No, there is no place there you can see the capacitance, but in this there is a place, the same place where we are putting right now, which is a resistance, which is ohms. You can measure capacitance as well. All right. So, I will give a capacitor to him, he will connect it or he will insert it in the breadboard, and then we will see the value of the capacitance on the multimeter. So, let me read the value. The value is 10 microfarad. So, let us see. So, again let us see how he has inserted the resistors. You see, I told you that you can insert it like this only when you are not considering the central portion. The central portion, that side is one connection in series, this side is one connection in series. But so you can connect resistors like this. You see, resistors are like this. All right. Same way capacitor he has connected, but you see another two different area. Okay, one pin is here, another pin is here. Now, let us measure the capacitor. So, you can see, you can change the selection, you can bring it, or with this mode button you can change it, right, and you can bring it to capacitance mode. So, now it is here, which is your micro nanofarad, it is nanofarad. So, let us see. Right, what we see is around 9.77 microfarad, correct, 9.77 microfarad, and the value on the capacitor is about 10 microfarad. So, it is close, all right, 9.77 microfarad. Now, let us see another capacitor. Ceramic capacitor. So, again capacitors are several types. Again, this is not a scope of this particular course, but that can cover under a different course on semiconductor devices, where we can see what is then within the capacitor, what are kind of capacitor, what kind of diodes. But right now, let us see if the ceramic capacitor is there, which is in my hand, and I am giving to Sitaram. So, let us see how we can measure the capacitance of the ceramic capacitor. So, again he is inserting the capacitor in the breadboard, right. He is using the same multimeter, and when he is connecting with the probe, we can see the value of the capacitor, which is around 464.1 nanofarad, right, 464.1 nanofarad. You can always convert to microfarad if you want, it is very easy. So, the point is, this is so easy to use, extremely easy to use, right. How about we have a diode? If we have a diode, can we measure with both the multimeters? Yes. You see, in this multimeter there is a symbol for diode here, where my finger is there, diode is there, and in this particular multimeter, same point we can measure diode. All right. So, I am giving him the p-n junction diode, which we have seen in the last lecture, the p-n junction diode. Now, he is connecting p-n junction diode to the breadboard. Let us see. Okay. P and N, P and N. I told you there is a silver ring on the diode, that is easy way of identifying it, but we have to measure the diode with the multimeter. So, let us see with multimeter. First, we are looking at the multimeter, which is 603 from Mako. This is yellowish one, yellow color, and let us see the which is anode, which is cathode. It is easy to identify if you can see some value. Yes, right. So, what we are connecting right now is a diode, and if we connect it the positive to the anode and negative, that is ground to cathode, then only we will see this value. If we change the probe, that is if we change the value, that is negative or ground to the anode, and the positive terminal to the cathode, then you see you cannot see anything. Can you see anything in this one? No, right. So, it is very easy to identify which is anode, which is cathode. Again, once again, let us see, this is the right connection, we are connecting ground to cathode and positive to anode, we can immediately see the change. So, this is very easy to identify the diode is anode or diode is cathode. Same way, if you want to use this particular multimeter, right, and we are measuring the diode. So, again using the mode function we can change it to diode. It is very easy. There is a symbol of diode here also. So, when you press the mode, this particular yellow color button, you will see the change here. Now it is diode. Let us see when we are connecting positive to anode, ground to cathode, we are again looking at the some voltage, right. So, it is easy, we identify that yes, this is anode, this is cathode. If you do reverse thing, we will not be able to see anything, correct, easy. So, what we have seen here? We have seen diode, then we have seen resistor, we have seen capacitor, we have seen bigger capacitor. Now, it is it's kind of it looks very beautiful, because if you see from smaller to bigger, actually diode is also a little bit big in terms of he has placed the components, it looks good. Alright. Now, let us see the another one, which is the transistor. So, whether the transistor is NPN or whether the transistor is PNP, how we can know? Now, you see in this multimeter that you see here, there is no functionality that we can measure the transistor. Here we can directly place a transistor and know whether it is NPN or PNP by keeping it in this particular mode, which is HFE, I told you last time, and there is nothing but the beta, and we can measure whether it is NPN or PNP. Now, the one that I am holding in my hand, he will insert it and he will and we can see the display, and we can identify whether this is NPN or PNP transistor. So, he is placing this in NPN to start with, and he can see some value which is around 145, 130, 107, keeps on fluctuating. How about he keeps the same thing in the PNP side. So, in the multimeter itself is there NPN, PNP, you have to connect it. Okay. So, when you connect it to PNP, see no change, you see this is PNP side, he kept this thing, the transistor, in PNP. Earlier he placed in NPN. When he was placing in NPN, he could see the change in some value. Here when you see PNP, the HFE, there is no change, right. That means that this is not PNP transistor, it is not an PNP transistor, and it is an NPN transistor. Let us see the another transistor then. How about this transistor that I am giving it to him, and this is another transistor. So, again he is trying to keep it in NPN. So, let us try with NPN, first one, and as you see there is no change. Can you see any change? There is no change, right. So, that means that this transistor is not an NPN. Is it PNP? Let us see. See, there is a change, right. So easy to identify whether it is NPN or PNP. Alright. So, what we have seen? We have seen the role of multimeter to understand the discrete components, But can a multimeter be used to measure the AC voltage? Can a multimeter be used to measure AC voltage? So, yes, it is there, right, because we have a knob that we can connect it to this particular value here. So, you can now take it out, this transistor, alright. Now, let us keep it to AC, and to understand whether we can use it for AC or not, we need to have another equipment called variable AC or variac, which is VARIAC. So, old variac with me. Now, the way I have placed here, you see lot of time we do this mistake, you can zoom out. This is wrong. You should not place a component over each other, right. This is not a circuit, this is not this thing that you can place it like this, right. Never place your electronic components one over each other. This is a wrong way of operating the system, wrong way of using in the laboratory, right. always remember, when you start the experiment your table should be clean, when you leave the experiment your table should be clean, right. You should understand how to work in a laboratory, and that is called good laboratory practices. How to enter the lab, where to keep the bag, how to use the components, how to place the equipment, that is how it is very important, alright. So, like I said, we should not place on it, we are placing it next to it, alright. This is very heavy, right, because there is a transformer, heavy. Alright. Now, we are connecting this to the power supply. And we have switch on the power supply. So, now if you can focus here, you see you can change the voltage from 0 to 230 volts. It is connected to where? This is connected to the power supply, this is connected to the 230 volts AC, alright. So, now what is the voltage across these two terminal? If I want to measure what is the voltage across this two terminal, I can again use a multimeter, alright, any multimeter. So, if you see there is a multimeter here, if you see there is a multimeter here. So, let us see whether Sitaram can get any voltage or not, alright. Let us see. So, he is connecting the red and black, right. Now, this you can connect in any way, it is a AC, you can connect it in any way, does not matter. You will see the change, and I will then tell you what is that. You can connect it now, right. So, what you see in my hand here, right here, is about 19.4. I have kept around 20, right. If I keep on increasing, you see, you can see keep on increasing. What is this? These are AC voltage, AC voltage. We can vary the AC voltage, that is why it is called variac, VARIAC, variac. Okay. So, right now what we see is we can change the voltage, I am increasing the voltage, and correspondingly I can see the increase in the voltage here on my multimeter. So easy, extremely easy. Now, you know what is the voltage at the output of this particular variac, correct. We can keep on increasing, you can keep on increasing, same way if I keep on decreasing, it will come down, it will come down, it will still come down, right, same way. Now, what is the frequency? There is another thing, right, but what you have seen is you can connect it, connect the probe, and you can see the voltage. Same way you can do it with another multimeter, which is your this one. Can you please connect it? Connect it to here. That is fine, I can hold it. So, again he is connecting this multimeter, right. It is in AC mode, we can see the change, right, we can see the change. I am increasing the voltage, right, and then I am again increasing it 105, 120, 134, 138, 146. Now, I am bringing it down, so it is coming down, right, comes back to almost 0 because now there is no voltage. So, around 0.0 or 52 millivolts, right, 9.095, 0.96, right. So, this is how you can measure the voltage. This is what we are measuring, AC voltage. Now, if I want to measure the frequency, can I measure the frequency, right. So, let us see what is the frequency here. Connect it to frequency, yes, it is a mode of frequency. Now, he will again connect it to the same one, this is 230 volts, alright, and we all know what is the frequency, we will see, even we know, we see. Here 49.85, 49.86, close to 50 hertz, right, close to 50 hertz, alright, thank you. So, what we saw right now, right, in this set of experiment is that we can measure. So, after you use it, right, after you use it, okay, you should immediately switch off the power. switch off the power before you start working on other parts, or you note down in your notebook, or you log down the results in your system, right. First thing that you do is you switch off the power, alright. So, I am switching off the power, I am taking it out all the way, right, because I do not want to use it, right. So, I am done with this. So, this is how you should take it out, do not just keep it connected. I do not need it, I do not use it, I just disconnect it, always be safe, right. Safety is extremely important, alright. So, again a part of your good laboratory practices, cool, alright. So, wherever we have seen the multimeter and the role of multimeter to measure several things, right from different devices, discrete devices, right. Then we have seen transistors, both the transistor PNP and PN transistors, right. Then we have seen the voltage, using the variac or varactor, and we have also seen the frequency. Now, why it was close to 49.86 something? Because in India, right, if we measure the voltage would be single phase 230 volts and the frequency is 50 hertz, right. However, if you go to some countries, you will also see a voltage which is 110 volts, but in that what is the frequency? The frequency is 60 hertz, right, 110 volts 60 hertz, 230 volts 50 hertz, right. So, the point is that is also another topic, that which one is better, 110 is better, 230 volts is better, but if you take an example of a electronic equipment at our home, for example juicer or a trimmer, it can operate on both the voltages. If I go to US, I can use it at 110 volts 60 hertz, if I come to India, I can use it at 230 volts 50 hertz. So, that is there is a separate issue, that what is within it, so that it can operate on both the voltages, both the frequency. The point here is that using the multimeter, can you measure voltage, can you measure frequency? The answer is yes. Can you measure resistance? Yes. Capacitance? Yes, right. NP and PNP? Yes. DC voltage? Yes. DC current? Yes. AC voltage? Yes. AC current? Yes. So, when you say a lot of time, yes, it looks good, but the point is multimeter cannot solve everything. Can it give you DC power supply? It cannot give, right. How multimeter operates, that is another thing. So, if I start giving a voltage, right, some voltage is there, constant current is there, what is there, constant voltage is there, constant current is there, there is a question, right. What is within the multimeter that operates the multimeter? I told you there is a battery, right. So, if you see in some multimeters 9 volt battery, some multimeter is different. The point is what is the operating, what is the mechanism, how multimeter operates. So, that is the something that you have to learn. You see, I told you in my first class that do not rely on instructor to tell you everything, right. Instructor is there to tell you the ingredients, he will show you how to make tea for one time, not every time, right. So, every time when you have to do, you have to explore what to add, what not to add, how to use the components, right. But at the same time what you learn here is what is safety, right. If you do not know, you ask before you use it, alright. So, we will stop this particular module right over here, because in next set of modules we want to see the equipment starting from the DC power supply. So, you see here in front of me is a DC power supply. If I remove this, you can see very clearly what is there. There is a DC power supply, and here also is a DC power supply. So, in the next like I said module, we have to see how the DC power supply operates, and what are the kind of DC power supply, is it variable DC or is a constant. And then in following modules we will also see different equipment such as function generator, we will see oscilloscope, right, and then we understand that how we can use this all the equipment to solve some electronic circuits, or to use different experiments to analog experiments, right. You want to measure, for example, the inverting amplifier, how inverting amplifier operates, right, how non-inverting amplifier operates. So, if you want to understand this thing, we have to use this equipment, and before we use this equipment we should know about this equipment. So, the next set of modules is to understand the equipment, and then we will move on to actual experiments using this equipment and using the discrete components along with your integrated circuits. All right. Thank you, and I will see you in the next module.